In this video, we are going to discuss some problems on forced response for the differential equation. And here we are having a problem 6 dy of t by dt plus 18y of t, which is equal to 2 times x of t, where y of t is the output and x of t is the input, and input x of t is given by 2 times u of t. Okay, in the previous video we solved natural response. This is the continued part of that video. We are going to solve the forced response for the same problem. If you haven't studied the natural response, please go back to the previous video, and we have solved natural response for the same equation. Okay, and in this problem we are having inputs x of t given by 2 times u of t. Let us solve this. Forced response consists of two terms. First one is a term resembling natural response. Okay, the forced response consists of two terms. First term consists of a natural response, a term resembling a natural response, and the second term is a particular response, or we can call it as particular solution. Okay, better word is a solution. First term resembling a natural response, and the second one is a particular solution. Okay, let us solve this problem. Yf of t, forced response yf of t is equal to, first term is natural response yn of t plus a particular solution yp of t. Okay, now we are having a forced response consists of two terms, marking it as equation number 1. Okay, and from given 6 dy of t by dt plus 18y of t is equal to 2 times x of t, mark it as equation number 2. From this equation number 2, we can write the characteristic equation. We can write the characteristic equation as 6r plus 18 is equal to 0, marking it as equation number 3. To know about the characteristic equation from equation number 2, please go back to the previous video, and in the natural response I have explained clearly about the characteristic equation, how we got 6r plus 18 is equal to 0. Okay, now from the equation number 3, we can write r is equal to minus 18 by 6, or we can say it as minus 3. The value of r is minus 3. Since we got the value of r as minus 3, we can write the natural response yn of t. Yn of t is equal to c times e power rt. C times e power rt, which we can write as c times e power, the value of r is minus 3, minus 3t. Yn of t is c times e power minus 3t, marking it as equation number 4. Now we got the natural response. In equation 1, we are having natural response and a particular response, particular solution. Now we got the natural response, and we need to find the particular solution. Okay, moving on to the particular solution. For a particular solution, it depends purely on input. Particular solution depends purely on input. Okay, and here we are having the input and the particular solution table. If the input is a constant, if the input x of t is a constant, particular solution yp of t will be a constant k. Okay, if the input x of t is a times e power minus at, then the particular solution is k times e power minus at. And similarly, if the input is a times cos omega t plus phi, then the particular solution will be k1 cos omega t plus k2 sin omega t. Okay, in this problem we are having input x of t is equal to 2 times u of t. Okay, since x of t is 2 times u of t value is 1 between 0 to infinity. It is a constant value. U of t will be constantly 1. Okay, and 2 is also a constant. Since x of t is a constant, input is a constant, the particular solution yp of t will be k. Therefore, yp of t is equal to k. Okay, marking it as equation number 5. Now, substituting equation 5 in equation number 2, here we are having equation number 2 is the given expression 6 dy of t by dt plus 18y of t is equal to 2 times x of t is the given equation. Now we are going to substitute y of t as a k. Now we will be having 6 times d by dt of k, since y of t value is k, plus 18 y of t value is k, 18 y of t, in the place of y of t we have replaced it by k, which is equal to 2 times x of t. X of t value is 2 times u of t. Right? Now, differentiation of a constant is 0. Remember, differentiation of a constant is 0 plus 18k is equal to, the value of u of t is 1. 1 into 2 into 2 is 4. Therefore, k is equal to 4 by 18, which we can write it as 2 by 9. The value of k is 2 by 9. Now we are having yp of t is equal to k. Equation 4 represents a natural response and equation 5 represents a particular response. If we add these two, we will be getting the forced response yf of t is equal to, from equation 1 we are having yn of t plus yp of t, and yn of t is c times e power minus 3t plus yp of t is k. The value of k is 2 by 9. I can mark it as 2 by 9. Okay, remember we still need to find the value of c. In a forced response, remember, for forced response, initial conditions are always 0. For forced response, initial conditions are always 0, which means y of 0 is 0, y dash of 0 is 0, y double dash of 0 is 0. Similarly, all the initial conditions are always 0 for forced response. We are forcing to get the response by assuming initial conditions as 0. Now, yf of t is equal to c times e power minus 3t plus 2 by 9. Right? This is our expression, equation number 6. Equation number 6. Now, we are going to put t is equal to 0 in equation 6. We get y of 0 is equal to c times e power minus 3 times 0 plus 2 by 9. Right? Since y of 0, initial condition y of 0 is always 0 for a forced response. Okay. Therefore, e power 0 is 1, c plus 2 by 9 is equal to 0. That means the value of c is equal to minus 2 by 9. Now we got the value of c. Substituting the value of c in equation number 6, we'll be getting y of t is equal to, the value of c is minus 2 by 9 c times e times minus 3t plus 2 by 9. I can rewrite it as taking 2 by 9 common, one minus e power minus 3t. 2 by 9, 1 minus e power minus 3t. We're taking 2 by 9 common. Therefore, this is the forced response for the given expression. 6 times dy of t by dt plus 18y of t is equal to 2 times x of t, where the input x of t is given by 2 times u of t. Okay. Since in this problem we have taken a input as a constant, okay, this is the answer that we got for a constant input. Okay, remember we are having different particular solutions for different input cases. Okay, let us consider the same problem. Let us consider the same problem. 6 times dy of t by dt plus 18y of t is equal to 2 times x of t, where input here in this case input x of t is equal to e power minus t into u of t. Okay, I am taking the same problem, only the input is replaced. Previous problem input was 2 times u of t, and here it is replaced by e power minus t into u of t. Okay, let us start the solution. Forced response yf of t is given by combination of two terms. One is yn of t plus particular solution yp of t, marking it as equation number 1. Okay, for this the characteristic equation remains the same, and it is given by 6r plus 18 is equal to 0, right? And from this we can write r is equal to minus 3. For r is equal to minus 3, yn of t is given by c into e power minus 3t. Remember, for this equation natural response remains the same. Okay, marking it as equation number 3. And for this input x of t, for x of t is equal to e power minus t into u of t, particular response yp of t is given by, here we are having a into e power minus at, will be getting k into e power minus at, and u of t is a constant and its value is 1 between 0 to infinity, and e power minus t. Since u of t and here we are having 1, there is nothing, we can consider it as 1. We can write it as k. To replace constant, we are replacing constant by k, and e power minus t. Here we can see e power minus at remains the same, only a is replaced by the constant k for a particular solution. So I replaced the constant u of t by k, and e power minus t remains same for a particular response, marking it as equation number 4. Substituting the value, equation 4, substituting equation 4 in given expression, 6 times dy of t by dt is replaced by 6 times d by dt. The value of y of t is replaced by k into e power minus t, plus 18 y of t is replaced by k into e power minus t is equal to 2 times x of t is replaced by e power minus t into u of t, e power minus t into u of t. Okay, differentiation of e power minus t is 6 times e power minus t minus into 6 times e power minus t. K is a constant, we can keep it outside. K. Okay, K is a constant, we can keep it outside. K. Plus 18k into e power minus t, which is equal to, since u of t is u of t value is 1 between 0 to infinity, we can mark it as 2 times e power minus t. I can take e power minus t common in this equation. Will be left with e power minus t to 18k minus 6k is equal to 2 times e power minus t. E power minus t get cancels, and 18k minus 6k is 12k is equal to 2 here. From this we can write k is equal to 1 by 6. We can mark k is equal to 1 by 6. From 12k is equal to 2, we can get the value of k. Okay, substituting equation 4 and equation 3, substituting equation 4 and equation 3 in equation 1, we'll be getting yf of t is equal to, natural response is same, c into e power minus 3t, and a particular solution is k into e power minus t, and the value of k is 1 by 6. We can write it as 1 by 6 times e power minus t. 1 by 6 times e power minus t. Marking it as equation number, equation 4 was there, now here we are having equation number 5. Okay, as I said, for forced response, initial conditions are always 0. That is, y of 0 is equal to 0, y dash of 0 is equal to 0, y double dash of 0 is equal to 0, and so on. And substituting t is equal to 0 in equation 5, we get y of 0 is equal to c times e power minus 3 times 0 plus 1 by 6 times e power 0. E power 0 is 1, and the value of y of 0 is 0. C plus 1 by 6 is equal to, c plus 1 by 6 is equal to 0. Therefore, the value of c is equal to 1 by 6. We got the value of c is equal to 1 by 6 by substituting t is equal to 0 and getting y of 0 is equal to 0. For this problem, we don't need y dash of 0 and y double dash of 0 and so on. We only need y of 0 is equal to 0. Okay. In some cases, when the degree of equation is 2 or degree of equation is 3, we are going to need a y dash of 0 and y double dash of 0. Okay. Now we got the value of c, substituting it in equation number 5, we'll be getting yf of t is equal to 1 by 6, sorry, the value of c is minus 1 by 6, okay, here it was plus, minus 1 by 6 e times minus 3t plus 1 by 6 e power minus t, and we can rewrite it as by taking 1 by 6 common, 1 by 6 e power minus t minus e power minus 3t. This is the forced response yf of t for the given problem. If you people have any doubts, please do comment on my chat box, will be connected. Okay, thank you.